Previously, we talked about k combinations, namely how we can determine how many k combinations there are of a set. Remember that this is where we don't care about the order elements appear. We just care about if an element appears or doesn't. So we're trying to find out how many subsets of a set contain of a certain size k. So here, in that case, we did not allow there to be repeated elements. Now I want to talk about if we introduce the ability to include repeating elements. So now we're going to talk about k combinations with repeats or repetitions. So k combinations with repeats. Or repetitions. So we're going to be talking about k combinations with repeats or repetitions. Remember, as I just previously stated, in permutations, we care about the order they are in. In combinations, we do not care about what order the elements appear because we're considering subsets of a given set of size k. Now, in the case of k combinations, we forbid repeated elements. Now we're going to see what happens if we allow that to be the case. So consider k combinations where we may reuse elements. Now we're going to need a somewhat different object to represent these things because a set isn't just simply, remember, sets don't contain duplicates, right? So what are we going to use to represent this? Is we're going to use something called a multiset. So we represent each such selections as a multiset. So a multiset is just simply a set where you're allowed to include duplicates, and we count the duplicates. So I write it slightly differently first, just to keep it clear. We're going to use square brackets as opposed to curly brackets. So we're going to use these, not those, because these indicate that there are no duplicates allowed. This one allows duplicates. Now, I want to answer a question, is if I'm allowed, and keep in mind, I'm going to show you some examples, but one question I really want to address is how many k combinations with repeats are there for a set A? So the way I express these is using a multiset. So each listing is going to be a multiset. So one way I can view this, so I'm going to view this in a somewhat different way. So we're going to view the elements of A as buckets to place objects. One for each in A. And then we pick k elements. We pick k elements of A to go into the buckets, right? Because remember, we don't care about the order. We just care that it appears or it doesn't appear. So if I choose 2 of the first element, I want to make sure that that is clearly evident to go into the buckets. And we choose these, right? Yes, Miss Kitty, I know. We're going to choose them, right? That's something that's really important for us, Miss Kitty. So, just as an example, I'm just going to show you what all of the k combinations would look like with repeats for the following set. Suppose I have the set A. We're going to look at the 3 combinations with repeats of this set, A, B, C, D. all the 3 combinations with repeats, and I must stress the repeats part is important, are. So I could pick the set, I could pick the element A 3 times. So this is how I would write the multiset. So I have 3 A's. Then I could have A, B. So I pick A twice, and then B once, and C no times, and D no times. I could have A, C. I pick A 2 times, C once, no B's, no D's. A, D. Then I have A, B, B. So I'm going to try 2 B's. Yes, Miss Kitty. I know about that one. I know about that one. I'm getting to it, Miss Kitty. I'm getting to it. It's coming on the board. Yes, yes. So I have A, B, B. Then we have A, B, C. Then we have A, B, D. Then we have A, C, C. So notice that the game in town now is I pick 3 elements, but I'm allowed to reuse them. So just to be very clear, like I could make all of them the same element if I wanted to. So I have A, C, C. I have A, C, D. And I think I have A, D, D. So these are all the ones that start with the letter A in the first position. Now let's consider the ones with B in the leading spot. So I have B, B, B. So I can pick all of them to be B. No A's, no C's, no D's. Then I have B, B, C. Then I have B, B, D. I have B, C, C. I have B, C, D. I have B, D, D. So those are all the ones that start with a B. You could double check these. I encourage you to do so as an exercise. I have C, C, C. C, C, D. And then I have C, D, D. Then next, and finally, we have all D's. D, D, and D. There should be 20 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20 possible. 20 possible 3 combinations with repeats of A. So remember, the order does not matter. It is what's in there. But now we're allowed to have repetition. Now, to make this easier for us to think about, now remember, I talked about it like you have a certain number of A's, I have a certain number of B's, a certain number of C's, and a certain number of D's. And I can think of them like placing the elements in buckets. Now, I need a very natural way of talking about one bucket versus another bucket. So I could break them into the different buckets and talk about the different bins and how many are in there. So a very standard way in combinatorics is to go back to our friend, the string, and represent it as a string instead. So let's represent the buckets as lines. So these are bars, actually. I should call them lines or bars. So that's a bar or a line. And elements in a bucket as a dot. So just as a quick example of what I mean, if I look at A, B, and C, where's A, B, C? It's right here. A, B, C, a way I could represent this is as follows. So I could put a dot, line, dot, line, dot, line, and that's it. So notice that this says that there's 1 in 1 of A. So there's 1A. This says there's 1 of B, 1 of C, and then this says there's 0 D's, right? So you could conceivably, well, you should be able to find for any one of these multisets, you could build a string like this of just lines or bars and dots. That's it. So you're breaking each one of the buckets. I need some way of representing the buckets. So these separators are being used to represent the separation between my different buckets. So just another example, just to illustrate the point. Let's look for let's go BCC. Where's BCC? Ah, there's BCC. Let's go with this one. So, for example, there are no A's. There's a B. There are 2 C's, but there's no D's. So there's no A's, 1 B, 2 C's, no D's. So that's an example of a string of bars and dots that represents BCC. Let's do another one. Let's go the AAA. So I would have 3 dots, bar, bar, and bar, right? So this is just three dots for the 3 A's and nothing else. So for every one of the multisets, I could represent it as a string like this. Now, let's ask a question now about these strings, because now that we've described it in a much simpler way, we can come back to talking about positions in a string and the placement of the dots. Just like in our example that we talked about, actually when we were talking about K combinations, we actually talked about placing ones in a binary string. So we could take the same idea. So how long is a string of dots and lines? How long is one? Well, let's think about it. So how long is it? Well, you're going to have, okay, how many bars are there? For example here, notice that I have four buckets, right? To separate them, I use 1 less than the number of buckets. Because that means that there's exactly, if I have n buckets, how many lines are there? There's n minus 1 of them. Well, there's n minus 1. So this is the number of bars or lines, plus k, which is the number of dots, right? We always have k of them in there. Which I'm just going to rewrite as n plus k minus 1. So there's this many positions in the string always. And now that we have positions in a string, and I know how many elements I'm going to pick, do you see how this is actually an exercise about how many ways the dots can appear in the string, because everything else becomes just a bar, right? So it's just the exact same exercise as this. So we select k positions of the n plus k minus 1 many positions. So just to be very clear, you would imagine this as a set that it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, where the last position is n plus k minus 1. And then you ask the question of how many k combinations there are when you select over this set. And that's exactly what we're dealing with. It's just an extra elaboration on this idea. So we select k positions for the n plus k minus 1 many positions. To place the dots. All others are for bars or lines. Hence, the number of k combinations with repetitions or repeats is n plus k minus 1 choose k. So notice that really, we're really dealing with the same kind of problem, just we have to think about it a little differently. Kind of like our example when we talked about k combinations, we talked about finding the number of 8-bit strings with exactly 5 ones in them. We're actually answering a very similar question to this, just I've recast, instead of thinking of a binary string, you can think of it just as lines and dots.